Hey, welcome back, and thanks for joining me for another episode of Hey, are you sure you should be doing that? Today we're going to be having a look at this piece of commercial kit. It's called a door strike. Now don't say that too loud because we don't want doors to get any ideas. Now, this one's okay because it's been disconnected from the hive mind here, so there's no chance of it communicating what it learns to the other door strikes. So we're going to have a little peek at this and see why it's not working. Now, if you don't know what a door strike is, that's only because you didn't know what to call it, because these are fairly ubiquitous. Anytime you're getting let into an apartment building, this is what's letting you in. Normally what happens with a door strike is it sits on your door frame, like so, and there's the little pokey bit that comes out of the door and interacts with the hole in the door frame. You've seen this. You know what I'm talking about. And then when you turn the handle, it retracts that, and the door opens. Now, this is just slightly different in that these little gates here, when you apply a current to this end, will allow the door to open. So you don't actually have to turn the handle like a chump. Now, in order for this to work, both of these gates have to release to allow the door to open. So if this is the deadbolt for your door, it's going to interact right in here in this hole, and then when you apply a current to this end, these gates will open and it'll allow the door to swing open. So in this case, what we've got, I've just got 12 volts hooked up over here. And why am I using 12? Well, it says right there, 12 volts DC, so that's kind of handy. So we're just going to apply 12 volts to this, and you can hear the click, and this one is open, and this one is not. So we got a problem on that end. So you can see how that would work. Now, to replace one of these things is over $300, so it's worth having a look at seeing whether you can fix it before you have to replace it. So really, there's not much to this. It's a lot of metal and not much else. So what we're looking at here, these are the working components. These are the solenoids, and they're what allow these things to open up. And I'll see if I can demonstrate that here. Let's have a look at what is going on here. So this is a solenoid. It's really just an electromagnet, and there's a metal pin in here, and when you apply a charge, what will happen is this metal pin will retract, and in doing so, it pulls that lever back. Now normally the lever is preventing this gate from opening, but when it gets retracted, then it allows that to slide through and the gate opens. And then there's a spring here that just returns the solenoid back to its original position once power is cut off to the solenoid, and then it's locked again. Now what we've got going on over here, however, so this one is locked, and you can see that if I press it in, it stays that way. It's actually all seized up on the inside, so that pin no longer functions, or the solenoid is seized up in some way here too. So anyway, this is obviously what we need to replace, and so we'll pull this off and have a look at the part number and see if we can't source something. So there it is there. Make sure you don't lose your spring. This thing will fuck right off on you if you're not careful. As soon as your back's turned, it'll be gone. Put it someplace safe. So normally these pins would just be loose, but it's real tight. So something's happened on the inside of that to cause that to seize up. You can see that the label's melted, so this got hot at some point, and there's even a burn through mark in the insulation right there. So this thing's totally hooped. Now it looks like the part number is a little bit hard to read. Maybe we'll look at the other one to see if we can find out what that is. It looks like we're looking for a solenoid with a part number of SH0424, 1224 volts. So we'll have a look for that on the internets. And here we have the manufacturer of that solenoid, Shin Technology out of Taiwan. But of course it's not listed here. Closest we can come is 0421, but the 21 here on the end is the length of the solenoid, so that's 21 mil, and it's just a little too small. So I suspect that this was one of these custom designed solenoid, and it's not listed here either, but you know, probably they made it special up for this particular project. And yeah, anyway, we're out of luck. Got to figure something else out. All right, if we're going to replace this solenoid with something that's going to half-ass fit, we're going to need the dimensions of it. So we'll just take some readings here. It looks like it's 25, let's say 25 millimeters wide or long. And, oh, actually, you know what? Why don't we measure the cavity that it actually has to go in? That would make more sense to me, I think. So this is, yep, 25 millimeters long. And this dimension is 14 millimeters. What is that, the height? And then finally, we're going to actually have to get the width from here. And it is, well, we'll call it 12 millimeters high. No, what did I say? Wide. eBay turned out to be a total bust. I found one, but see, the problem here is the, how do I get that to stay? Okay, so when it pulls, it pushes out the back. So we can't have that, right? It's got to be self-contained within the solenoid itself. So that's just no good. I ordered it anyway because, you know, we could probably drill some holes to allow for that, but it's not ideal. These little guys could take up to 3 months to get here because somebody decided to start a pissing match with China. I did search a bunch of domestic electronics suppliers, but I really couldn't find anything that was quite right. And then one day, just out of the blue, I get an email from Allied, who I'd completely forgotten about. And wouldn't you know it, they've got a very close match to what we're looking for. Not perfect, but close. I've ordered them. When they come, we'll have another stab at this. Hot damn, Christmas come early this year. And I'm not just saying that because, well, this. You know, I never noticed what a severe overbite a poo has. Damn. Must be a bitch eating corn on the cob. So here's what we ended up with. It's not a dead-on match, but it's pretty close, I think. If we slot it into our mechanism here. Oh, we'll have to take this out because that's not quite the right size. Oh, and I've gotten it backwards, like an idiot. Okay, so you can see it does slot in fairly well. Nothing a little shim won't take care of. It'll take some jimmying, there's no doubt about it. Now the other issue is everybody's favorite sex ed topic, shaft diameter. Our original is around 4.5 mil, whereas the new one is about 4. So we're half a mil off. Oh, this thing, not good. Horror freight here. Look at that. You can't get this thing to 0. What the hell's up with that? Jeez, piece of garbage. Just a sec. There you go, much better. It's a little bit more money, but kind of worth it. So we'll switch to mil here, zero it out, and we'll see what we've got here. So 4 3/4 for that, and for this around 4. So we are 3/4 of a mil off, which means we're gonna have to do something about that. Now there's a couple options here. One is to try and create the same profile we've got on the original on this shaft, or well, actually that might not be too bad of an idea because it looks like we could, yeah, that's a possibility. The second option is to try and grind this down to the appropriate thickness, and then you actually have the same flanged end here to catch in the lever mechanism. So those are our options here. The other problem with the new solenoid is that one contact at the back there is resting right against the metal frame, so that can't happen either. So we'll have to insulate that from the, maybe we can just bend that forward and get that out of the way. Maybe that won't be so bad. If we're going to swap pins on this thing, we're going to need to know the depth, like how far that thing is going in. So I'm just going to mark that here. And we'll compare that with our other one. So that's it there. This pin, oh, so that means it's going to stick out. Let's see here. The whole pin sticks out about 9 mil. And normally this sticks out, oh, like not much at all. We're looking at maybe 5. So there's another problem there. Since I don't have any use for this pin anymore, what I think we'll do is we'll start with this one, and I'm going to try and grind this down to the proper diameter, and we'll see what happens after that. Now I got nothing for metalworking equipment, so I've mounted that pin in my drill press here, and I've got a piece of aluminum oxide. This is a little old piece, so it's not going to wear down this pin too quickly. Let's give it a go. We're shooting for 4 mil. Okay, here's my modified pin. So I took a little bit off, and here's our solenoid, and actually it fits quite nicely. Now, to be fair, this is not perfect. This is a little fatter at the top than it is at the bottom, but it's a nice fit. So now the problem is that the shaft is actually too long. And so what we're going to have to do is we're going to take some off of this end, keep it pointy, and make it fit closer to the base. Alright, here goes nothing. So I think that's fairly close. There's a little slop in that mechanism, so I think it'll be okay. I just want to taper off this end, and it's going to need a little bit of I need to take this down a little bit more in order to get it to fit. I don't know why I didn't think of this before, but I could have used a file. Perfect. No problem. Alright, shall we see if this thing still works after all the abuse? And contact. And that seems alright. Looks like we're in business. Happy, happy, happy! Yes, I know what that looks like. So, does it actually work in the door strike? That's the question. Now, remember that spring I told you not to lose? Yeah, you all thought I was crazy. Who's crazy now, huh? Okay, so it returns, the spring returns the thing. Now let's just see if the solenoid will retract it. There we go. Oh yeah. And yep, we're in. So I think we're good. What's the problem now? The problem now is it's kind of loosey-goosey in there, and we need to shim this up nicely. So we'll figure out how to do that, and of course wire it properly so that it's not grounded against the frame. Alright, before we get too deep into the shimming action, we're going to wire some leads onto this solenoid here. Yep, we're good. Now, what we've got here, this stuff, heat shrink tube. You know about this? Whoever invented this stuff should have got a Nobel Prize. Now, for all your young kids out there, you probably don't remember, but back in the day we had to wrap wires with electrical tape. This stuff, you know? Oh, so irritating. Alright, so now, hopefully we can just slide that all over the entire contact, like that. That should protect it quite nicely, and then shrink it down. Good luck doing that with electrical tape. They're not too bad. And as for our fit in here, yeah, you can see that it's well protected from the frame there. So we're good. What to do? What to do? So the best way I think to go here is there's a little notch out right there, and I'm just going to take a piece of just a tiny piece of aluminium and just wedge it into that corner. So just like that. So that seems like a fairly reasonable solution. I don't feel like that's going to fly off or go anywhere. It's pretty snug in there, so I think we can just wire it up and throw it together. Oh, what's going on? Why is that sticking? What's going on here? Oh, it doesn't like my wedge. Yeah, not good. Okay, so it turns out that the wedge is a real problem here, because it's causing this to bind up. I wonder how much problem we would have with that if we just left it off. If you look on the inside here, there's an upper cage as well. So that must fit over top of that, which seems to me to maybe be enough to hold it in place. It really doesn't seem like it's rattling around or anything in there, so that might be just fine. Alright, it's all back together. I've got it hooked up to the little switch here, so we're going to test it out and make sure it's functioning the way it should. So here we go. Both gates are open, so that's good. Let go of the switch, and we're locked again. Door goes open, door goes closed. Door goes open, door goes closed. Okay, I think we're okay here. It seems like it's working just fine. So the question is it worth $300? Well, it's a nice piece of metal, but I'm not so sure. There's not much else to it than that. The little solenoids are the only thing that's really going to go wrong with this. So if you have one and it's broken, that is almost undoubtedly where the problem lies. And it's also quite easily fixable. So there's not much more I can say about that. Thanks for watching. And I gotta say special thanks to everybody who made it through the entire video and actually do not have a door strike and will probably never own one. So the only thing I think you can get out of this video for that is you can pretty much fix anything, you know, if you just take it apart and have a go at it. Most things are repairable. So hopefully that's the lesson here. I don't know. Thanks for watching. Cheers.